solving for sides using the primary trigonometric ratios. First, let's learn how to do some algebra here. So if you solve for the unknown in the following, here we have sine 35 equals x over 8. So you have an x, an unknown value, being divided by 8. We use the same kind of rules as we did with linear systems. So we would multiply both sides by 8 right here. Okay, 8 times x over 8 times 8, that will cross out. And so now we have x equals 8 times sine 35. And if you go into your calculator and type in 8, you find your sine button. So hit sine and then type in the number 35. And you'll have to make sure that your calculator is in degree mode. And if you punch that in, you get x equals 4.6 about. So x equals 4.6. Here we have tan 62 equals 3 over y. This one's a little bit more confusing in terms of solving for your y because you have an unknown on the bottom. So I like to multiply both sides by y because this makes things a little bit simpler because now these y's cross out. So you have y tan 62 equals 3. And if you're trying to isolate y, we should divide out the tan 62 because remember that just represents a number. So tan 62, this crosses out. And now we have y equals 3 over tan 62. And if you go to your calculator again and you punch in 3 divided by and then find the tan button and 62, you'll get the answer is approximately 1.6. Now, I don't like to do the same thing multiple times in a long method. If I see a trick, I go for it. So I want you to notice this tan 62 equals 3 over y. This step right here, step number 1, became this right here. Okay, in the third step here, it was y equals 3 over tan 62. And note that here the unknown was in the bottom, and what happened was tan 62 and y simply switched places to get our second final step there, the third step in our solution, and then we just type that into our calculator. So notice that you can simply switch the sine, cos, or tan value with the unknown in the bottom. Here, we had the unknown on top, we multiplied by the denominator. So pay close attention to when the unknown is in the numerator and when the unknown is in the denominator, and then we'll make some quick steps to solve from there. Okay, so now let's apply this to an actual triangle. Here's our steps. We're going to identify the given angle that we are solving. Step number 2, we're going to identify one side we know and one side we don't know that we're trying to find out, let's say. And step number 3, we're going to write the appropriate trig ratio using number 1 and 2 and then solve. So let's identify the given angle you are solving. No, not that you are solving, the given angle. Sorry about that. So let's identify that. Well, here we have this angle. This is the angle that we know. So I'm going to draw a stick-it right there. Okay. From stick-it's perspective, we're going to identify one known side. So the known side is right here, which we would call the adjacent side. Notice it's beside angle A. And then we identify one unknown side. So the unknown side is x. And this side is the opposite to A. So we ask ourselves, well, what trig ratio uses opposite and adjacent? So this is from the last lesson here. We got SOH, CAH, TOA. So what trig ratio uses the adjacent and opposite? Well, sine uses opposite and hypotenuse, so that's not right. So we're not using the hypotenuse. This one uses adjacent and hypotenuse. We're not using the hypotenuse again. Tan uses opposite and adjacent. So we're going to use the trig ratio of tan. Okay? So to write this, let's go back up here. So tan of an angle is equal to opposite over adjacent. So tan of the angle, and here we have the angle as A, is equal to opposite over adjacent. So let's fill in what we know. Tan of A, well, A is 55. The opposite side is x, and the adjacent side is 6. To solve for x, we're going to do what we did up here. So we're just going to multiply by the denominator. So we're going to multiply both sides by 6. What happens here is these 6's cross out, and now we have 6 tan 55 equals x. And we can type this into our calculator. So 6 times tan 55, and we get x equals 8.6 approximately. Okay. Next example. We have triangle x, y, z. So again, we're going to identify the given angle. So we are given this angle right here, angle Z. We're going to identify one known side. So we know this side right here. And from Stickett's perspective, this side right here is called the opposite. And then we're going to identify one unknown side. And that's this side right here. And this, because it's across from the 90-degree angle, is called the hypotenuse. Now we're going to write the appropriate trig ratio using number 1 and 2. So what trig ratio uses the opposite and the hypotenuse? So opposite and hypotenuse is right here, the sine ratio. So we write sine of Z equals opposite over hypotenuse. That's the definition of sine. So we get sine. We fill in our unknowns here, or knowns. So Z is 40 degrees, so sine of 40 is equal to opposite. Opposite side was 15 over hypotenuse, which is x. Just like in the example above, when the unknown is on the bottom, remember that we can just do the switch here. So we're going to switch the x with the sine 40. Just do the switch. So we get x equals 15 over sine 40. Again, if you type this into your calculator, so 15 divided by sine of 40, we're going to get x equals approximately 23.3. And there you go. We just solved for the unknown sides in a right-angled triangle.